The James Webb Space Telescope, JWST, was designed to peer into the earliest light of the cosmos, and it has now delivered data so unsettling that a Nobel Prize-winning physicist has broken his silence with one simple, terrifying message: this is not our universe. What exactly did the James Webb Telescope find at the very edge of everything, and why are scientists warning that it could rewrite the very foundation of cosmology as we know it? Keep watching, because what you're about to hear changes everything. In a corner of the sky filled with ancient light, the James Webb Telescope captured what looked like a simple yellow splotch. But when astronomers took a closer look, their assumptions collapsed. That tiny glowing blob wasn't just another galaxy. It was the most distant galaxy ever seen, formed just 290 million years after the supposed birth of the universe. But here's the impossible part: it's too massive, too bright, and too evolved to have formed so soon after the Big Bang. By our current theories, there simply wasn't enough time or matter to form galaxies like this in the early universe. And yet, here it is. And it's not alone. Webb has now found dozens more just like it, each one a cosmic paradox, breaking every rule we thought we understood about the early universe. Scientists began to dig deeper, and what they found was even stranger. Some of these early universe objects aren't just massive, they're completely foreign to anything we've seen before. Unlike normal galaxies, which convert about 10% of their gas into stars, Webb discovered at least 3 galaxies that have turned 100% of their matter into stars. No gas, no dust, just pure, blazing starlight. That's not just unusual. It's impossible according to every existing model of galaxy formation. So now, scientists are asking a far more terrifying question. What if these aren't galaxies at all? What if we're not seeing the early universe but something else entirely? A structure from another dimension, a remnant of a previous cosmos, or an intrusion from another universe altogether. To understand why this is shaking cosmology to its core, we need to talk about the Hubble sphere and the observable universe. The farther away an object is, the faster it moves away from us due to the expansion of space. At a certain point, called the Hubble sphere, galaxies are moving away from us faster than the speed of light. Common sense says we shouldn't be able to see those galaxies, yet we can. That's because space itself is expanding, and the boundary of what we can see keeps stretching. But beyond that boundary lies something terrifying, a region of the universe that we will never reach and that will never reach us. And yet, the James Webb Telescope is now picking up light and signals from these impossible zones, light that should never have reached us, which leads to one conclusion: we are seeing beyond the edge of our universe, and no one knows what lies on the other side. Webb's data is forcing scientists to ask the unthinkable: what if the universe never had a beginning? Some Nobel laureates are now openly questioning the Big Bang model. Because if galaxies could form faster than physics allows, if light can reach us from beyond cosmic boundaries, and if structures appear that defy time scale and mass, then maybe we've misunderstood everything. Maybe the early universe isn't early at all. Maybe what we're seeing isn't a timeline but a fracture, a place where 2 universes overlap, or worse, where something far older than our universe is bleeding through. Whatever it is, it doesn't fit into our models, and it never will. Among the James Webb Telescope's most overlooked discoveries is not a visual image but a strange frequency. While measuring the background noise of the universe, Webb's instruments detected a faint rhythmic oscillation, one that does not match any known cosmic phenomenon. It's not a pulsar, it's not gravitational waves, it's not cosmic microwave background distortion. This frequency repeats at precise intervals, as if it were generated. Some astrophysicists have started calling it the heartbeat beyond time. Others are more cautious, suggesting it might be a signature of exotic matter, something that could exist only outside the boundaries of our universe. And here's the chilling part: this frequency is not random. It follows a mathematical pattern, as if something or someone encoded it to be discovered. One of the telescope's unexpected findings is a huge imbalance between what we see and what we feel. Galaxies located at the farthest distances appear to have enough gravity to bend light, distort space, and even affect surrounding structures, yet no visible matter is present. This isn't just dark matter, it's something else. Some researchers now believe Webb is detecting massive gravitational anomalies that don't correlate with any known source. These phantom mass fields act like cosmic fingerprints, pressing down on space-time from a place we cannot see. But where are they coming from? Some theorists are beginning to suggest the unthinkable: we're seeing the shadow of another universe colliding with our own. What if everything we see has a mirror image we cannot see, not metaphorically but physically? A fringe theory once dismissed by mainstream cosmologists is gaining traction again: that there exists a mirrored universe where time flows in the opposite direction and the laws of physics run backward relative to ours. What's changed? The James Webb Telescope has captured evidence of particle behaviors and rotational patterns in distant galaxies that suggest a symmetry, as if two different cosmic systems are overlapping. It's as though our universe is being pulled in one direction while another, just out of reach, is moving in reverse. If true, we may not be alone in the multiverse. We may be entangled with a shadow reality that reflects our own. In a final twist, one of Webb's long-range instruments was tracking a light signature from the edge of the observable universe. It was expected to fade. It was expected to disappear forever, as most light from distant sources eventually does. But then, something unprecedented occurred. The signal reappeared. Not from the same direction, and not from the same moment in cosmic time, but with the same spectral fingerprint. The same light signature, as if it had somehow rebounded, echoing across dimensions or timelines. This anomaly isn't something the current laws of physics can explain. Buried within static and radiation was a pattern, structured, intelligent, impossible. A neutrino signal. Voyager 1 shouldn't be capable of detecting neutrinos. It doesn't have the instruments, and yet the signal it sent was real, repeating, and mathematically precise. What did Voyager 1 intercept in the void of space? A glitch? A cosmic anomaly? Or something that confirms what many feared all along, that we are not alone, and the universe just answered back? Voyager 1 systems are almost 50 years old, powered by a decaying nuclear battery. It was built to measure plasma, radiation, and magnetic fields, not neutrinos, those ghost-like particles that pass through stars, planets, and even humans without a trace. Detecting neutrinos requires underground labs the size of football fields. And yet, Voyager's latest transmission contained a structured neutrino oscillation pattern so precise that it mirrored theoretical models never seen in nature. NASA and CERN were the first to notice. At first, they assumed interference, a glitch. But the pattern held. Mathematical. Repeating. Deliberate. Voyager 1 had received something that it never should have. To make sense of the transmission, scientists turned to AI deep learning systems originally developed to detect alien signals. And that's when things got worse. The AI found not just repetition, but prime number sequencing within the neutrino oscillations, a hallmark, according to SETI researchers, of non-natural communication. This wasn't like pulsars. This wasn't a magnetar flare. This was something else. Something with internal logic, symmetry, and intention. CERN's top physicists couldn't explain it. NASA's engineers ruled out all possible spacecraft malfunctions. So they asked the unthinkable, did Voyager 1 just intercept a message? The global scientific community has now split across three terrifying possibilities. Theory 1. Voyager has encountered a new force of nature, evidence of sterile neutrinos, long theorized but never proven. If true, this could rewrite the standard model of physics. Theory 2. Voyager didn't detect neutrinos at all, but intercepted a neutrino-based signal from deep space, a message, perhaps, from an unknown cosmic intelligence using neutrinos to communicate. Theory 3. The least fantastic but equally disturbing possibility. Voyager's systems were altered, interacted with, changed by something in interstellar space we don't understand. Each theory carries weight, and none have ever been observed before. Voyager's power is fading. Within a few years, maybe sooner, it will go dark forever. And yet, in its final moments, it has delivered one last enigma. Now the race is on. NASA, CERN, IceCube, and other neutrino observatories are analyzing decades of past Voyager data to see if this pattern appeared before, unnoticed. Voyager 2 is being monitored for anything similar, and ground-based detectors are now listening for neutrino signals from space. But there's one truth no one can deny: Voyager 1 has already heard it, and no one can explain how or why. While NASA publicly downplays the anomaly, leaks from internal sources paint a very different picture. Shortly after the transmission, emergency briefings were held with the Pentagon, the European Space Agency, and top-tier scientists from Russia, China, and Japan. Why the sudden urgency? Because if this neutrino pattern was sent, if it was deliberately encoded, then someone out there sent it. And that possibility isn't just scientific, it's geopolitical. The real fear isn't what Voyager received. It's the question no one can answer: who or what knew would be listening? As experts dug deeper, a disturbing truth began to emerge. The signal didn't seem to be aimed at Earth at all. Its structure, timing, and trajectory suggested it was targeted elsewhere, toward a region far beyond our solar system, deep in the galactic void. That led to a chilling possibility. Voyager 1 wasn't the recipient. It was the bystander. A witness to a message passing between unknown entities. And if that's true, then we weren't meant to intercept it. We were never supposed to hear it. And now that we have, what happens next? Among a small group of theoretical physicists, a radical new idea has emerged. They call it the contact threshold, the point at which a civilization becomes capable of receiving messages not bound by light, radio, or even time. Voyager, drifting in silence beyond the heliosphere, may have crossed that threshold, not because it was fast, but because it was quiet. In doing so, it may have triggered a recognition protocol, a kind of cosmic handshake reserved